All right, let's break down one of the most important papers in the entire history of AI. Back in 2017, some researchers at Google dropped a paper called Attention is All You Need. And look, it didn't just move the goalposts, it created a whole new sport. So, to really get why this paper is so critical, especially for anyone looking at a career in this field, you've got to ask this one question. See, before 2017, AI had this huge problem with language. It basically saw a sentence as a line of dominoes. You had to knock over one word to get to the next. But that's not how we understand language, right? We see it as this complex web of meaning. And the solution to teaching a machine to see it that way, well, that changed everything. Okay, let's get into it. To really appreciate the breakthrough, we have to look at the old way of doing things. This was the time of recurrent neural networks, or RNNs, and they were built on this idea of processing everything step by step by step. Imagine you're reading a really long article, but by the time you reach the final paragraph, you've totally forgotten what the first paragraph was about. That was the fundamental issue with RNNs. They process data sequentially, just one word at a time, and that created this massive bottleneck. Not only was it slow, but it really struggled to connect words that were far apart. A pronoun at the end of a sentence might refer to a person mentioned at the very beginning, but the model would just lose track. And this table right here just nails the difference. With the old recurrent models, the processing time grew with the length of the sentence. A longer sentence meant a longer wait. It's as simple as that. But with self-attention, boom. It can process a short sentence or a huge paragraph in basically the same number of computational steps because it looks at all the words at once. This wasn't just a small improvement, it was a total paradigm shift. So, in 2017, this team of researchers comes along with this frankly radical idea. They asked, what if we just got rid of sequential processing altogether? What if we built a model that could see the entire sentence all at once? And you can see it right there in the paper's abstract. They called their new architecture the transformer, and it was built completely on this mechanism they called attention. They just threw out all the old sequential parts that pretty much everyone else was using. I mean, what a bold move. And boy, did it pay off. So what does this new architecture actually look like under the hood? Let's take a little tour of the blueprint that powers basically every major AI you hear about today, from ChatGPT to all the others. The whole thing has two main parts. Over on the left, you've got the encoder. Its job is to read and really understand the input sentence. Then, on the right, you have the decoder, which takes that understanding and generates the output, like a translation. It's just a really elegant design that quickly became the new industry standard. So both the encoder and the decoder are made of these stacks of layers. The original paper used 6 for each. And the key thing is inside each of these layers, they completely ripped out the old recurrent parts and replaced them with two new things, a self-attention layer and a simple feed-forward network. And that self-attention part, that's where all the magic happens. Okay, so let's get to the real secret sauce of the transformer. Let's see how this thing builds that deep, connected understanding of language. This is the concept that unlocked absolutely everything. Put simply, self-attention lets the model, for every single word it's looking at, pay attention to every other word in the entire sentence. It looks forwards, it looks backwards, and it calculates a score for how relevant each word is to the current one. This is exactly how it builds that web of relationships we were talking about earlier. So how does it do this? Well, through a process called scaled dot product attention. Here's a kind of cool way to think about it. For every word, the model creates a query, which is like the word asking, hey, what other words are important for me to understand my context? Then, for every other word, it creates a key, which is like a label that says, here's the kind of information I have. And finally, a value, which is the actual substance of that word. The model then matches the query against all the keys to find the best matches, and then it pulls information from the corresponding values. That's how it decides what to pay attention to. But, the authors figured out pretty fast that just looking at a sentence from one angle, well, that's not going to cut it. Language is way too complex and nuanced for that. A single word can mean different things and have different relationships all at once. So they came up with something called multi-head attention, and this is just brilliant. It lets the model read the same sentence from multiple viewpoints at the same time. The original paper used 8 of these heads, so it's kind of like having 8 different experts read the same sentence. One might focus on grammar, another on who's doing what to whom, and so on. It creates a much richer, deeper understanding. So the theory is fantastic, right? But did it actually work? I mean, how did this new model perform when they put it to the test on one of the toughest challenges out there, machine translation?
Well, the transformer didn't just perform well, it absolutely demolished the competition. On a key English to German translation task, it set a new state-of-the-art score of 28.4. Now, that number comes from something called a BLEU score, which is just a way of grading how close a machine's translation is to a human's. And beating the old record by over 2 full points, trust me, in the world of machine learning, that is a massive, massive leap.
And this right here, this is the crucial point, especially for anyone wanting a career in AI. Take a look at that training cost. The transformer got better results using a fraction of the computational power. And why? Because its whole design can be parallelized. It can be split up and run all at once on modern computer chips, like the GPUs in your gaming PC. It was better, it was faster, and it was cheaper to train. That is the trifecta that kicks an entire industry into high gear.
Look, this was never just about making translation a little bit better. This paper laid the architectural groundwork for nearly every single major AI model that you hear about in the news today.
So the takeaway here is crystal clear. The transformer architecture is the engine of the modern AI revolution. It's the reason we have large language models like BERT and the whole GPT series. Because it allowed for parallel training, it suddenly became possible to train on these insane internet-scale datasets. So for anyone building or working with AI today, understanding the transformer isn't just, some academic exercise. It's absolutely essential. This paper fundamentally changed our entire approach to machine intelligence. It showed us that sometimes, to solve a really hard problem, you just need to pay attention to the right things. It was a paradigm shift that defined an entire era. And it leaves us with one final fascinating question to think about. What's the next big idea that's going to change everything all over again?